a slight tilt of the head, a raised eyebrow. For all our complexity, the output channels for our thoughts are remarkably primitive. We squeeze the vast, branching universe of an idea through the tiny keyhole of muscle contractions, whether it's the vibration of vocal cords or the tapping of fingers on a keyboard. But what happens when the keyhole is sealed shut? In locked-in syndrome, a mind can be fully aware, thinking and feeling, but unable to move a single muscle, besides perhaps the eyes. The entire galaxy of consciousness is trapped behind a wall of unresponsive biology. This isn't a failure of the mind, it's a bandwidth problem. The processor is infinitely fast, but the connection to the outside world is severed. The bottleneck has never been the quality of the thought, but the physical apparatus we are forced to use to express it. The brain, however, is never silent. It is a constant storm of electrical activity. By placing electrodes on the scalp, we can listen in. This is electroencephalography, or EEG. But listening to EEG signals to find a specific thought is like trying to hear a single person's whisper from outside a deafeningly loud football stadium. You can tell when the crowd roars for a goal, a massive coordinated event, but you can't pick out an individual conversation. Early brain-computer interfaces leveraged these roars. A P300 speller, for instance, flashes letters at a user and detects the brain's tiny involuntary jolt of recognition when it sees the one it's looking for. We aren't reading the mind. We are reading the mind's reaction to an external stimulus. We are translating the intention to move a cursor, not the abstract thought of what to write with it. It's a clever but indirect hack. So, what if the output of one brain's roar could become the input for another? In 2013, this happened. A researcher in India thought about moving their hand. An EEG cap read the signal. A computer translated it into binary and sent it across the internet to a colleague in France. There, a transcranial magnetic stimulation, or TMS, machine converted the binary signal back into magnetic pulses. The French researcher, blindfolded, suddenly perceived flashes of light, a phosphene, in their peripheral vision. A single bit of information, a binary yes, had been transmitted from brain to brain. Scientists have gone further with rats, networking their brains to share sensory data, allowing one rat to use the neural information from another to solve a puzzle. This is not language. It's a dial-up modem for consciousness, a crude, noisy, but functioning first step. Sending a yes signal is not the same as sending a thought, because you don't think in ones and zeros. You don't even really think in words. Words are compressed files, lossy formats for enormous multisensory concepts. Consider the idea of a tree. When you think tree, you aren't just seeing the letters T-R-E-E. You are experiencing a cascade of associated data. The particular green of a leaf in summer, the smell of pine needles after rain, the rough texture of bark against your fingers, the memory of climbing a specific tree as a child. This entire bundle of experience, this quale, is the real thought. True brain-to-brain communication wouldn't be sending the word. It would be sending the bundle. The receiver wouldn't hear tree. They would simply and suddenly understand tree with all the personal weight and context that you do. If communication can become perfectly lossless, what happens to the self? Our sense of identity is fundamentally built upon the privacy of our own consciousness, our unique interpretation of experiences. When your specific personal quale of sadness can be directly transmitted and fully experienced by another, is it still uniquely yours? The boundary begins to blur. If we can share thoughts as easily as we now share data files, we might become nodes in a larger, distributed consciousness. Your memories, their skills, another's perspective, all accessible. The very idea of a singular, isolated I could become a relic. Speaking without moving might be the final evolutionary step away from the individual organism, transforming us from a collection of discrete biological entities into a single planetary thinking system, where a word is no longer needed because the feeling is shared by all.